Welcome, everyone, to today's Tech Talk. I'm very happy to introduce you today to k0smotron, a very early project about a Kubernetes control plane manager. So this Tech Talk is the first part of a series of other Tech Talks about k0smotron as well, because there are a lot of integrations. So today we exclusively look on k0smotron. And in the upcoming Tech Talks, we will talk about automation, for example, with Cluster API and much more. Feel free to connect on any channel. There are a couple ones that I added here. So feel free to reach out to me and have a chat with me. So today's agenda, we will first have a look into what k0smotron is. What problems can we solve with k0smotron, or what problems are there in the industry and with our customers too, where we see those problems? How k0smotron can help? How it works? So the core concepts of k0smotron, and we'll have a look into an example and a demo. And at the end, there will be time for Q&A. So let's get started. k0smotron is a Kubernetes control plane manager. What does that mean? We can run Kubernetes control planes within k0smotron. So k0smotron is a management cluster. And for any other Kubernetes cluster that you want to run, you can create control planes as a workload running in that management cluster, which allows fault tolerance, automatic, and can leverage the automatic failover capabilities of Kubernetes, and simplifies cluster operations. Because if you talk to this cluster, to this control plane of a specific cluster that you've created, you're talking directly inside of your management to that cluster. We have full separation of controller and the worker control and the worker plane, something that is very unique to k0s itself. So functionality that we can leverage includes including the connectivity agent. We'll have a look into that as well. And it's all built on decorative APIs. So we have in-cluster state management in the management cluster. So if you want to include it in any kind of GitOps model or GitOps approach, that's possible. And it's all based on the CNCF conformant Kubernetes distro, k0s. Let's have a look into the problems we see with customers. When we talk to customers, of course, before they go with k0smotron. But what problems can it solve? First of all, what we hear very often is that customers or enterprises out there have maintenance challenges. So it gets very complex to manage all the different Kubernetes clusters that are out there. Most of them have like multi-cloud strategies. So you have like an EKS cluster in AWS, you have an AKS cluster in Azure, and also you have like a couple of on-premises Kubernetes clusters, which of course creates this cluster sprawl and complexity. So the problem is here that it's not consistent across those public and private clouds, right? So you have a Kubernetes cluster, a kubeadm cluster on premises that you manage yourself, which is very different to the Kubernetes you can manage with EKS, for example. You have different versions that are available to you, and all those different managed services that are out there have different APIs and different versions of Kubernetes too. So you need to handle those different flavors. The footprint, of course, is one big part too. If you want to use k0smotron, on Cosmotron, if you want to use a Kubernetes cluster in a public cloud that is not a managed Kubernetes cluster, let's say a kubeadm cluster again, then you need to have a look into how to get high availability of your control plane. You need to have a look how to integrate that into the public cloud. And the footprint of those clusters always include 3 nodes for the high available control plane. And you have to secure the Kubernetes APIs in those different environments. So you need to have a look, of course, how to at least make your APIs as secure as possible and close any security vulnerabilities by yourself. Now, where can Cosmotron help with this? Cosmotron, first of all, is a single pane of glass, a secure single pane of glass. It offers a way for standardization in those private, public clouds, but also in edge or other environments, on premises, on bare metal. So you have one consistent Kubernetes distribution or Kubernetes flavor everywhere. And of course, you can do this with other Kubernetes distributions as well. But I will introduce you to something that is unique so far to Cosmotron that lowers the footprint as well in those target environments. So you have a central way of communicating with Kubernetes clusters or the Kubernetes API. This, of course, allows consistent operations just because of the standardization and, of course, also the simplified maintenance. When we now look into how that works, is that Cosmotron is nothing else as a Kubernetes controller, a service that is running in your Kubernetes cluster. It's not bound to your k0s clusters. It can be installed in other Kubernetes clusters as well. But in this example, we have a k0s cluster as the management cluster. On top of that, we have the whole Kubernetes API machinery. So this allows us to create custom resource definitions. For example, we can persist all of the information that are saved as the k0s control plane. And we have the Cosmotron controller that can create and manage k0s control plane. Those k0s control planes are sitting in that management cluster as a workload. And those control planes have 2 exposures. So 2 ports that need to be opened, which is the Kubernetes API port. So just a very simple, normal 6443, and the connectivity agent. And a connectivity agent is something that helps to tunnel traffic between worker plane and control plane. So the worker nodes that are running in different clouds, for example, or anywhere, and the control plane that is running in our management cluster. So if we look into k0s, the k0s control planes, I've already mentioned CRDs, custom resource definitions. So the core concept is a custom resource definition that we are creating with the Cosmotron controller. This custom resource definition is helping us to create clusters, and the Cosmotron controller will reconcile those and have a look for all the different resources that need to be created for this cluster, for this control plane. So in this example, we have CRD that is called Mirantis, with the name Mirantis Labs Demo CP. So this one is our control plane. We have the k0s version in here, so we will use the open source k0s version 127.3, we can persist the state of the Kubernetes control plane. Of course, persistence is key for a Kubernetes cluster. And we can do that by either put it into empty.The, so very simple, or we can, of course, use PVs, so persistent volumes for that, or PVCs. We can have replicas, so in this case, we just have one, but of course, you can create a high available control plane too, with, let's say, 3 replicas, like 3 nodes for the control plane, the Kubernetes control plane. And we have the, as mentioned earlier, also we have the service that will be exposing to ports, so the API port and the connectivity port. In this case, we have a Kubernetes service type load balancer, but of course, this can be a node port as well, or you can specify something for internal usage too. So that is up to you. And as it says here too, the connectivity agent or connectivity allows tunneling traffic between control plane and the worker plane. So you don't need to open a bunch of ports. You can open just one, and it will communicate securely, tunneled, and encrypted through connectivity. So I've mentioned earlier that the k0s controller will the reconciliation. So the k0smotron controller will look into those CRDs as soon as they are applied, create all necessary components, and expose the Kubernetes API and connectivity service. As soon as we apply the CRD, the k0smotron controller sees this CRD and the Kubernetes API store and will create those control planes. Of course, now the question is, how does those control plane look like? If we look into a control plane on the right, you can see that we have a very simple way of creating control planes. That is because with k0s, we already have this capability of creating very small control planes or small bundle everything in one small service. And the control plane will be just one pod exposed by a service, and in this case, an external load balancer. So service type load balancer, and we have a volume here. And this volume, I've mentioned that earlier too, can be a persistent volume and or can also be an empty.The. So it's very up to you. k0s also, as it says here in the k0s management cluster, it can be an etcd, SQLite, MySQL, or Postgres SQL as well. So you can not only create etcd cluster state stores, you can also use, for example, the Postgres operator from Zalando to automatically create Postgres clusters inside of your management cluster for the k0s control planes. So in this case, we have a bunch of worker nodes here that are connected to the load balancer. When we now look into our demo, it will be a bit different. We'll just have 2, but 2 different ones. So I will create 2 worker nodes. One worker node is a Raspberry Pi that is next to me, and a second worker node will be a virtual machine that is running in Hetzner Cloud. The k0s management cluster is sitting inside of AWS. And we will create this cluster here, the CRD. k0smotron will see that, will create it, and will create all the dependent or all the necessary workloads in that management cluster. And we will attach those to worker nodes. So let's get started. First of all, to make it a bit easier for me now to show you all of that, I've created this management cluster already. So this management cluster is a K0s cluster running in AWS. But what I will do at the end of this session or today is uploading all the necessary files to create this K0s management cluster. So I will show you where to find the GitHub repository to create exactly what I'm presenting today to you. So this management cluster can now already be used. So what I did here, so I'm using Lens to make it easier to show you what is happening in that cluster. Of course, I can show you that with kubectl too, but Lens in this case is easier to visualize. So this one is a k0smotron cluster on AWS as mentioned. We have just two nodes, so one worker node, one controller, and of course not highly available, but just for reducing the footprint, I've just used two machines here. k0smotron itself can, or K0s can also be installed on one single node. In this case, I'm using two. When we look into the pods of this cluster, what is running in here, we can see the AWS controller manager, we can see the CSI controllers, and we see the k0smotron controller manager too. So exactly what you see here, you can create with Terraform and K0s CTL, a simple CLI to create a K0s cluster, where you can also bundle, for example, Helm charts for cloud integrations like AWS, Azure, or other clouds as well. So since we already have that cluster, we can now create our control plane. And I've mentioned earlier that it is a custom resource definition. So we can have a look into those custom resources, and there's something that is called k0smotron IO. So in here, we can see joint token requests and clusters. And this cluster will be created, and the k0smotron controller, as mentioned, will create all the other necessary files. So again, to make it as visual as possible, I will just use K0s, K0s management cluster to create this within Lens. So we will create a namespace called demo, and we will create this control plane. So a very simple one, K0s demo cluster. We'll put it into the namespace demo. We'll just give it one replica. We'll use the normal K0s image with the version 127.3, and we'll expose it via the load balancer. And in the background, that's why I've added the the AWS cloud controller to be able to create load balancers directly within AWS. So let's do that. And we already see here now that there's a new cluster. We can see that it's living now for some seconds. And we can also have a look into the workloads. So let's have a look into what is happening here. I would just shrink this. So we just see the demo namespace. We can already see there's one workload, a stateful set, that is running here for some seconds. And that is already our control plane. So this control plane now is exposed 6443 and 8132. And we can also have a look into the services and see that we have a load balancer service in here. And we already have address, which is cool. So we have a control plane that is already working and exposed to the outside. So To make it as simple as possible again, I have a command here to get the k0s demo cluster kubeconfig from the namespace demo, and I will put it into the file child.conf. All of that can be also found directly in here. So we can go into config, we can go into secrets, and we can see the secret here. And we can see also that it is a kubeconfig file. So let's have a look into our clusters, and I can see, okay, newly created one, and I can connect to that cluster here as well. Of course, this can sometimes take some seconds. It will be available very soon too. The next thing we do is to have a look into, as mentioned, this join token request. So now I have a control plane. It might not be completely ready because, of course, it's Kubernetes. It can be complex, and we are working with AWS as a cloud provider. So sometimes that can take some seconds too. But I've mentioned the CRD called join token request. And I will create one so we can take our or use our machines, Raspberry Pi and the Hetzner virtual machine from Hetzner Cloud, and add those to our cluster. So I will just create this join token request, and you can see that it's being created here. This will talk to the control plane, and the control plane will create this new secret called edge token. So I have the edge token in here that I can use now. And that's what I will do too here now is I will go to, on the left side, I have the Hetzner machine. On the right side, you can see it's a local machine, a Raspberry Pi. And what I will do here is just create a token file. That's an old one. I will create this token file, save it. I will do the same here. Let's create this token file. And now I can initialize the k0s cluster. But first, let's have a look again if we now can connect to this k0s cluster. That one is working. Have a look again into services. So this one is exposed. We have endpoints. So this one is our pod, and it's active for 5 minutes. So if AWS is ready, we are ready too. Let's check again. Okay, no problem. We can have a look into that in a minute too. Because what we now do is, first of all, we will prepare those two worker nodes. So we will install k0s to that. That's very simple because k0s is a single binary that is now executable. So it's already downloaded, and you can see that on the left side, it's Hetzner. On the right side, that's my Raspberry Pi that's connected via Wi-Fi. So this can take a couple of more. Yeah, but it's ready now. And what we now do is configuring the k0s service, so the single binary, with the token we just created. So this will create the service, but not start the service. So we can have a look into the service status of course k0s worker. As we can see, it stopped. Let's do the same for our second node. So this one will only show that it is now installed. And now we can start the service. But before that, I will have a look again into Lens to see if we have everything ready. So let's connect again to the k0s cluster. That looks better. So as mentioned, here I have my k0smotron cluster on AWS. And in here you can see the control plane isolation. So if I would give access, for example, to anyone outside, to like a developer or a group of developers, or to operators too, that should only care about the services that are running on that cluster, I can do this with the control plane isolation. So I have my controller now running in the k0smotron cluster, and I can connect directly to these load balancer service I've created and see no nodes, nothing in here too. So I can say all namespaces, so even core DNS and metric server did not start, because where should they start? So let's get back to our two nodes here. And since the Raspberry Pi will take a couple more seconds, I will start with this one. I can go back here, and I can already see Raspberry Pi here. So there should be a node, Raspberry Pi, that is now connected to that machine. If I go back here and say k0s start, I can go back here and I can see k0s demo node. So this one is my Hetzner node, and the Raspberry Pi is just next to me here and connected via Wi-Fi. So I can now create this clusters, very distributed clusters, we have like nodes within worker nodes within different clouds, and spin those worker nodes up wherever I need them. Of course, k0smotron can be installed directly in those different environments, so it does not need to run in AWS. You can create, for example, MetaLB services to get connected to that control plane that you've just created. But it's now possible to do all of that very distributed. As you can see, we now have a couple of services that are running here. And of course, we want to see a bit more perhaps, because currently if we click on cluster, it does not say a lot. So let's go and just create a Prometheus stack. So this one is a very simple installation of Prometheus and node exporter. So we can see what is happening in those nodes. As soon as that is working and running, we can see what is happening here. So a very simple way of creating big clusters within minutes, seconds. So easy to do. To make it easier to show what I just did, I will create a service. This service is just a hello world service. And I can also say replicas equal to, and let's see if it gets distributed to the two nodes. Yes, perfect. So you can see hello world. We have two containers running here, one on the Raspberry Pi and one on the k0s demo node, which is running in Hetzner. Of course, this Raspberry Pi needs a bit more time, but that's okay. And now to expose that, I don't want to create a load balancer. I want to keep it simple again. I will create a node port, and this node port will expose this service. Okay. Yeah. That is a problem of the image, because I don't have an ARM image for this hello world container. But if we have a look into the service, we can see that we have now this hello world on 30672. I will go to the node. Let's go to our k0s demo node. I have an external IP address. And I have my browser where I would just go to this address and use the other port that we've just created. We can see that we have this very simple Hello World container running on our Hetzner node. So as you can see, it's very simple to create those control planes. It's simple to attach clusters, attach worker nodes. So you can create very different, have different use cases, create use it for different use cases, have a different way of spinning up clusters. And if you remember, I've mentioned control plane isolation and the lower footprint in public clouds. It's very similar to EKS, for example, or AKS, managed service offerings. So you don't see the control plane. You're paying for a high available control plane. And with k0smotron, you can do the same. You can run this k0s management cluster, let's say, in your own environment. And you can spin up k0s clusters or worker nodes in AWS or in Azure. And you only pay for the worker nodes, only for the essentially for the resources that are really like giving benefits, that are running your business critical applications. Before we go into our summary, I just want to show again, we now have everything up and running here. So we should see that even Prometheus was can now be seen. No, not ready yet. Okay, then let's jump into the conclusion. So I've mentioned it's a single pane of glass for all Kubernetes clusters. Not for all, if we just look exclusively on k0smotron. k0smotron itself is a controller that can create k0s control plane. It reduced the footprint, as mentioned earlier, so you can have a similar experience as, for example, EKS or AKS. So you don't need to run the control plane within those different public or private clouds. It's consistent across a consistent experience, a consistent Kubernetes, and consistent APIs across those different clouds or infrastructures. It limits cluster sprawl because you have everything in the one management cluster, or if you want to, different management clusters for different projects, for example, or different environments. And this allows a wide range of use cases. And in the beginning, I've mentioned a way for integrating into a way of integration for Cluster API. And Cluster API, for those who've not heard about Cluster API, it's a sub-project focused on providing decorative APIs to allow provisioning, upgrading workloads or worker nodes in this case, and load balancers in different public clouds and private clouds. So this integration allows us to do the following, because when we look back to this one, we now have a very manual step of attaching worker nodes. But with Cluster API, the provisioning of all those worker nodes can be automated. So a very convenient way to go and create Kubernetes clusters, because what we do is we will create a bit different CRD, which is called k0smotron control plane. And you can create other CRDs to create worker nodes in very many different public and private clouds. So there are integrations for the for AWS, for Azure, even for vSphere or Cloud Director or any other public and private cloud. So a lot of different possibilities here. The second talk will be about, and will be on the 22nd of August. And will be about what is Cluster API again? How does k0smotron integrates into Cluster API? How does both work together? And we will have a look into creating clusters and creating clusters in AWS, Hetzner, on Docker, and even on bare metal with the power of Tinkerbell to create full bare metal clusters. And we will have a look into how to contribute. You can already contribute from now on, since the GitHub repository is public, available, and open source. But we also have a look into the roadmap for this open source tool. So what we are planning and what's next. If you have time, feel free to join me again on the 22nd, this time at 6 p.m. Central European time. And we will have a look into Cluster API and beyond. There are two links I have here in my Q&A slide. The k0s project GitHub link. So in the k0s project, you will find k0s, which is open source, and k0smotron, which is also open source and available for everyone to use. And of course, we are happy to see contributions to that repository as well, or to our project. And all the things I've done today in the demo will be also shared in this Mirantis Labs GitHub repository. If you are joining live, or if you're live here, it's not uploaded yet. I will push it today so you can see what I did, how I've created those, the management cluster and also the control planes, and how to attach those worker nodes and run a very simple Hello World container. Thank you, everyone, for attending this tech talk. There are two upcoming tech talks or webinars this month and early next month, and as mentioned on the 22nd of August too. So the next one will be about Edge and Far Edge Cloud, just with k0s on July 25th. Then we have the tech talk about Kubeflow, orchestrating AI workloads on Kubernetes, that I will present to you on August 8th. And we have, as mentioned, on the 22nd, another one that will give you a good explanation about Cluster API and how that works with k0smotron. Thank you very much, and have a nice day.